Welcome, ladies and gentlemen. So what I'd like to do is show you how to solve this equation, systems of equations, by substitution. And remember, when we're substituting, all we're doing is we're substituting in a value for a variable. So we got to look at, can we determine the value for exactly one variable? And fortunately for this system, it's pretty explicit, saying that this variable is equal to the expression 5d minus 16. So therefore, we want to take that expression and substitute it in for wherever we see the variable c in the other equation. Because to solve an equation, we have to be able to solve an equation only with one variable. So this is already solved for c, but we have d in the answer, right? That's like saying the vocab word, what is the definition of a word, and then using the vocabulary word in the definition. It's kind of still like an unknown, right? So what I'm going to do is, rather than using c in the second equation, I'm going to use what does c equal? Well, we know what c equals. It equals 5d minus 16. So when I do that, I write 5d minus 16 plus 2d equals negative 14. Now, what I have is an equation that has only d. So I know I can solve for an equation with only d's. So to do that, I need to apply a distributive property here. So I have 15d minus 48 plus 2d equals negative 14. Then I can combine these two. So I have 17d minus 48 equals negative 14. Add 48, add 48. 17d equals positive 34. Divide by 17, divide by 17. d equals 2. Perfect. So now I know what d equals 2. So to determine the value of c, all I simply need to do is, again, substitute in my value for d into an equation for d so I can find the value of c. So I can say c equals 5 times 2 minus 16. c equals 10 minus 16. c equals negative 6. So therefore, ladies and gentlemen, your solution set is d equals 2, c equals negative 6 for solving the system of equations using substitution. Thanks.